Welcome to this edition of Momentum. I'm your host, James Warnock. And my first guest today is Matt Dickson, who's the team driver for our Formula SAE car. So Matt, thanks for being on the show with us today. And first of all, tell me about Formula SAE and the competition. For people at home that don't know what it's all about, explain what it all is.
Well, we're an engineering design team. We're underneath the mechanical engineering department, but we have people of multiple majors, aerospace, mechanical. We have an electrical engineer. We design and build a Formula style race car and take it up to a competition in Michigan where we have judges on design and events like autocross and skid pad and Excel.
Okay, so how did you get involved with the team?
Well, I've always liked cars. My parents tell me my first word was car, actually. So it was just a natural fit for me when I came to school to get involved into the car team.
Okay, and presumably you're a mechanical engineering student?
Yes, sir.
And was that something that helped you decide on your major, just that love of cars?
Yes. I wanted to go into the automotive business and or even onto a race team. So this will be a great thing to put on my resume and a great thing to learn about that field.
Absolutely. So the competition runs in during the summer, but the team actually starts working on the car at the beginning of the fall semester.
For the most part, that's when it really kicks in, but we've already started designing for our next car now in June.
So tell me about that whole process. Do you start from scratch every year on this car, or how does that whole process work?
Yeah, we actually have to start from scratch and build an entirely different car every year. We have to design a new chassis. We have to design new ergonomic things, such as how the driver sits in the car, the steering wheel placement, different things to make the driver more comfortable. We have to make the car faster in any way we can. We need to make it lighter, and we have to research different ways to do that.
And do the specifications for the car change every year with the different competitions?
Every other year there's a new rule book that's released, but for the 2-year period that's the same. They may make minor changes, but there's no major changes.
Okay. And the students in the team, do you actually make all the components for the car, or do you buy things off the shelf from other manufacturers?
We buy a few things off the shelf, like the tires come from Hoosier and the engine comes from Honda. But other than that, it's all designed and manufactured in-house.
Okay, so you learn quite a few skills in terms of the manufacturing of the car, as well as designing and performance.
Yes, we get a lot of experience working hands-on on a car. We get a lot of experience using tools like a mill or a lathe to manufacture different parts, and then coming together as a team to build the car with your different sections. It's a really good experience.
And tell me about the competition itself. I know you go up to Michigan every year to compete, but how long is the competition, and what are the things that are involved with the competition?
Well, there's about 120 teams that show up from different universities across the world. There's a couple teams from Germany, but most are from America. We go up to Michigan to the NASCAR track that's in Brooklyn, and there are many different sponsors there. There is a Toyota booth that some of the less involved people can, if they're not working on the car at that time, they can go over there and test drive some of the Toyota parts. There's a lot of fun things you can do at competition. You can talk to other teams too. Most of the people on different teams are quite friendly and open about what they did to their car differently.
And in terms of the events of the competition, you mentioned autocross and skid pad. Can you tell me a little bit about those different things that go on at the competition?
Yes, skid pad, it's just a small figure eight that the driver has to do as fast as possible. Excel is kind of like a drag strip. You just go in a straight line as fast as you can for a set amount of meters. And autocross is close to a racetrack, but it's set up very tight with cones on the back stretch of the NASCAR track, which is pretty wide. And those are all the dynamic events that we do. We also do an endurance based off of the autocross, which is 22 kilometers. Each driver for the autocross does 11 kilometers.
Okay. Well, Matt, it's been great talking to you today. I wish you all the best and good luck with everything. We're going to be right back after we take a quick break here.
When you're the best, everyone wants to see what you'll do next. At Mississippi State University, our team of world-class rocket engineers is venturing beyond boundaries, building rockets like none before. We're launching a new era of space exploration. We've developed cutting-edge technology that's helping us build a rocket that can travel at 4 times the speed of sound. Fast? Yes. But more importantly, revolutionary. For you and for a space program that produces many of the conveniences we enjoy today. We're shaping your life in ways you never dreamed. What's next? Watch us and see.
Welcome back. My second guest today is the director of the Bobby Shackles Technical Communication Program in the Bagley College of Engineering, Mr. John Brocato. John, great to have you here.
Thank you.
Now, usually when people think of engineering, they think math and science. And so technical communication is more of the humanities, the English side of things. Can you tell me a little bit about the history of the program and how it evolved and how it came to be in the college?
Sure. So I was hired in 1999 to start the program and develop the required course for all engineering undergraduates. Prior to that, their writing experience at the professional level was handled through a course in the English department. And I had taught there as a lecturer for a while and heard about the job opening and applied and got it. And so I began, and this was right around the time of the new ABET criteria, right before the year 2000. And so we were hired to help sort of augment the communication experiences of students. And that's been our charge from day one, is to help undergraduate and graduate students in the college to improve their writing and their speaking.
And so when students come in your class and they say to you, why do I need to have another writing class? I've already taken my English comp. What do you typically tell them?
Well, I try to approach it via the Socratic method and ask them why are you here? Why do you think you're required to take this class? And of course, some of them say, well, just because we have to. And then we get past that and we talk about the actual reasons. And a few of them will eventually figure out, oh, I guess we're supposed to say that we're going to do this as professionals. And that's, of course, that's the answer. And that's, we extrapolate on that in class that, in fact, contrary to what some of the stereotypes would indicate, engineering is a very heavily communicative profession, especially in this day and age. And so even those students who may have gotten away from English or the humanities because they thought they weren't good at it and their strengths lay in math and science, the reality is they're going to have to do a lot of communicating. In fact, one of the most common things we hear from former students when they email us after they've graduated and entered the workforce is to tell us how valuable the class was to them, because they communicate way more than they thought they were going to, even though we told them that. They may not remember that we told them, or maybe they weren't listening at the time, but they realize, wow, this is something that I do a lot. I'm not using differential equations or lab procedures nearly as much as I am writing reports, writing emails, talking to people on an interpersonal level, leading panel discussions or talking to small groups and things like that. So we from day one, we introduced that it's not just a line on their curriculum or a box to be checked off, but it's actually something useful to them. And that's how we approach it. And we hope that they will take that away from the class.
And in the class, it's technical communication, so they learn to write, they learn to speak and present. But there's actually a little bit more to it than that in terms of what they learn in the class.
Right. So it comes in a sequence after Comp 1 and 2. So in a sense, it's a type of advanced competition, or advanced composition. It builds on Comp 1 and 2. And so we address matters more related to writing style and beginning to cultivate a professional writing style, and the same with presenting. Many of them have had public speaking or speech, and so we try to build on that as a foundation, to give them some more experience at it. But one of the main other modules that we get to in that class is ethics. We talk a lot about engineering ethics, and of course engineering ethics itself is a vast field, all on its own. So we look at engineering ethics through the prism of communication, because technical communication especially carries with it an innate ethical component, in part because of the types of projects that engineers work on that have such a direct impact on the public and on public safety. Therefore, the communication about those projects always has to show the writer as being honest, transparent, writing clearly. All the things that go into making good writing also make for ethical writing. And so we use a lot of different case studies, primarily the Space Shuttle Challenger disaster, because it's one of the more famous ones, but we look at some other ones too, the levees in Hurricane Katrina and the St. Francis Dam failure back in the 1920s, and look at the communication that was involved in that. In addition to that, we also do a lot with multidisciplinary collaboration, because our class is one of the few where every major is present at some point. And so we try to get them together in teams that they might not otherwise work in. And regardless of the makeup of the team, especially at their stage, having to work with other people and learn to compromise and communicate, clearly and be fair with everybody and uphold, their end of the bargain and so forth. They always need more experience with that, so we try to fold that in as well.
And the past couple of years, you've taken a class to Germany during the summer as well.
Right.
Can you quickly tell me about your experiences there?
Well, it was fantastic. It was the idea behind it was that a required class would make for a good study abroad experience. Because we might get more students in there, and so that's what we did. And so for those 2 summers, we went and did our class over there, and of course took advantage of the fact that we were in Europe and saw many cultural sites, and tried to fold in some things about Germany or German engineering into some of our assignments. And then we had saved some time to have some fun as well. But it was a really good experience for all of them. I stay in touch with all of them, and they talk about what a difference it's made and how it sort of broadened their horizons and so forth. So that was a really great experience for all of us.
Great. John, it's been a real pleasure having you on the show today.
Thank you so much.
That's all we have time for today. Don't forget, you can always follow us on social media through Twitter and Facebook at MSU Engineering. And that's our show for today. Thank you for joining us.